Welcome to This Explainer. Today, we're diving into a seriously mind-bending topological framework to uncover why physical matter actually has shape. It sounds like a philosophical riddle, I know, but the source material we're looking at provides a rigorously mathematical and frankly fascinating answer. We are literally exploring the geometry of existence itself.
So let's kick things off with a pretty basic question. When you picture a molecule in your head, what actually forces it to hold that specific, stable 3D structure instead of just collapsing into a tiny dot? We totally take it for granted that objects take up space, right? That a table feels solid, or that a water molecule has a distinct geometric angle. But why? What is the fundamental mechanism that prevents all these particles from just falling into a single chaotic point?
Section 1. The geometry of carbon, matter's shape.
To figure this out, we kind of have to start from the bottom up. 109.5 degrees. This specific number is the measured tetrahedral angle of a carbon-based molecule, like methane. If you were to look at a 3D model of methane, you'd see carbon right in the center and 4 hydrogen atoms spaced out around it perfectly, forming a tetrahedron. The angle between any two of those bonds? Exactly 109.5 degrees.
Now, standard VSEPR theory, valence shell electron pair repulsion, something you probably encountered in high school chemistry, teaches us that this shape is caused by electron pairs mutually repelling each other. We learn that negatively charged electron clouds just do not like being near one another, so they push away, spreading out as far as geometrically possible while still staying tethered to the nucleus. They are actively avoiding each other.
Which brings us to Section 2, the law of mutual avoidance, forced non-collision.
Let's reframe this. Instead of just a chemical quirk about repulsion, think of it as a profound geometric necessity. As the source material brilliantly points out, if you force 4 entities to move on a sphere and give them a single unbreakable rule, don't crash, they naturally settle into that exact 109.47-degree geometry. You don't actually need to tell them to form a tetrahedron. You just need to tell them to avoid overlapping. The tetrahedron isn't an input. It's the unavoidable mathematical output of 4 objects refusing to occupy the same space.
So here's the absolutely crucial takeaway. Matter's shape isn't just arbitrary. Shape is simply the physical manifestation of forced non-collision. The geometry of a molecule is quite literally defined by the spaces it is trying not to crash into. And the field of chemistry has been using this exact principle for over 70 years to compute molecular geometry. Section 3. Deleting the diagonal. Configuration space.
To really wrap our heads around the deep math of things moving without crashing, we need to zoom out into the world of topology and look at the actual shape of logic itself. Enter configuration space, or conf(n)x. This maps out the allowed states for multiple moving entities. Imagine tracking the positions of multiple particles all at once. Configuration space is the arena where all their possible locations are plotted, but with one incredibly strict boundary condition: they can never, ever touch.
Think about it like this. Normal mathematical space allows all coordinates, right? But configuration space strictly deletes the diagonal. The diagonal is just the exact set of points where collisions would occur. If particle A and particle B have the exact same coordinates, they sit on this diagonal line in our mathematical model. By deleting this diagonal, we are literally removing the possibility of a crash from the universe's available options.
When you literally delete those collision points, you create mathematical holes in the space. And the fundamental structure of those holes, that forms what mathematicians call the Braid Group. It's an incredibly cool, highly studied mathematical object that defines the shape of things weaving around each other without ever touching. The shape of things moving without crashing isn't just a fun metaphor here. It literally dictates what kinds of physical systems can actually exist in reality. Moving right along, Section 4. The quantum crash, amplitude structurally zero.
So, how does this purely mathematical concept of deleted collisions translate down into the raw quantum mechanics of our physical universe? Well, the answer is mathematically absolute. For identical particles, the amplitude for them to crash into each other is structurally identically zero. In quantum mechanics, the Greek letter psi represents the state of a particle. When you plug the exact same position into the quantum state of 2 identical particles, like fermions, the result isn't just, highly unlikely. It is exactly 0.
Because identical particles have what's called an antisymmetric state, if 2 particles try to occupy the exact same spot, the equation literally cancels itself out. This is tied to the spin statistics theorem, which basically says if you swap two identical particles, the overall state picks up a minus sign. So if they are in the exact same place, a value must equal its own negative. The only number that equals its own negative is 0. The universe doesn't just try to avoid the crash simply cannot compute. The avoidance is hard-coded right into the fabric of quantum math.
Section 5. Forbidding the fixed point, the first constraint.
Okay, so we know particles naturally avoid each other to form shapes, but what is the grand cosmic law making it mathematically illegal for them to crash in the first place? It all comes down to the first constraint, or C1, which states that nothing can fail to change. According to the source theory we're exploring, this is the absolute progenitor of structural reality. It means the universe simply cannot tolerate a frozen state, a stalled flow, or a permanent stopping point. To stop changing is to cease to exist.
Let's walk through the ultimate logic here, step by step. Step 1. When two entities share the exact same location, that collocation is a fixed point where relative change completely stops. Step 2. Because a crash is a fixed point where change dies, and C1 strictly forbids fixed points, we arrive at step 3. The universe must invent spatial separation, and therefore shape, just to keep changing. When two things collide and get stuck together, their relative motion drops to 0. But since C1 makes fixed points illegal, the universe enforces a strict rule: do not crash. And as we've seen, when things are forced to avoid each other, they generate geometry, they generate structure, they generate shape.
This brings us to a quote that brilliantly sums up the entire explainer. The shape of things, moving without crashing, is nothing but the holes where the crashes would have been. The solid shapes of matter we interact with every single day are quite literally just the mathematical holes left behind by forbidden collisions. Everything, from the carbon in our DNA to the steel in our buildings, owes its structural integrity to the universe relentlessly dodging a mathematical standstill. The shape is just the physical record of that endless avoidance.
I'll leave you with this final, kind of provocative thought to ponder. If the very existence of a molecule relies on its endless, restless need to avoid a fixed point, is matter actually an object, or is it just a temporary, frozen verb? It really makes you reconsider what it means for something to be solid, doesn't it? Thanks for joining me on this explainer. Keep questioning the shapes around you, and I'll catch you next time.